कोई भी इलास्टिक चीज होगी, whether it is your rubber band, a spring or anything, you stretch it. When it is new, you stretch it, it'll come back to its shape. But if you keep stretching it beyond its capability, तो वो थोड़े दिनों बाद क्या हो जाएगा, वो अपने आप को वो डी शेप हो जाएगा, वो अपने ओरिजिनल शेप पे वापस नहीं आएगा. Got it? So when we say that you stretch it and comes back to its shape, then we say it is following Hooke's law. But जब वो डी शेप हो जाता है तब वो फॉलो करना बंद हो जाता है, इसीलिए उसमें जो एक्सटेंशन होता है ना वो हमेशा के लिए हो जाता है. So what happens if you see the shape of this would be something like the graph would be, what do you see on the graph? On one side it is what?
Extension on one load.
X-axis, on the other side it is, X-axis पे क्या है? Load है, और Y-axis पे क्या है?
Extension.
Extension is the weight, is the extension which is happening. कितना खिंचाव, how much is the extension? अब आप देखोगे कि इसका जो ग्राफ बनेगा वो कुछ इस तरह का बनेगा. It will start from the origin. It will start from the origin, something like this. ठीक है. Just properly draw it. So let's have a look. So this is how एकदम straight line. But after some time, it just changed the shape. So what happened after this point? ये extension की वजह से इसका shape change हुआ. So it changed like this. It becomes curved. ये कब हुआ? जब till this point it was obeying Hooke's law. मतलब extension was directly proportional to load. Right? मतलब मैंने load बढ़ाया तो extension बढ़ा. Load बढ़ाया, extension बढ़ा. But एक point के बाद वो load को ले नहीं पाया और वो completely extend हो गया या वो टूट गया. ठीक है? Got it?
Yeah.
Right? Okay. State the words used to describe the energy. Now you're talking. Now it's asking you about question about energy. State the word used to describe the energy stored in the spring that has been stretched or compressed.
Elastic energy.
Okay. Stretched or compressed. Elastic बोलेंगे, उसमें एक और word था. What was it?
Elastic potential energy.
Elastic potential energy. ठीक है? Don't forget that. It is elastic potential energy. Read the next question, please.
Oh, figure 3.2 shows a model train traveling at speed v approaching a buffer. The train of mass 2.5 kg is stopped by compressing spring in the buffer. After the train has stopped, the energy stored in the spring is 0.48 joules.
Very easy question.
Yeah. Calculate the initial speed.
Okay. आप बताओ कैसे करना है इसको.
So the mass is given.
So we'll write M is equal to
force into.
No, M is equal to कितना given है?
Okay, 2.5 kg.
2.5 kg. Okay. और क्या है? What else is given?
Stored in the spring.
Energy. So energy कितनी है?
0.48 joules.
और निकालना क्या है?
The speed.
The
speed.
So v निकालना है, right? Initial speed. It is traveling at a speed v. Okay. कौन सा ऐसा फॉर्मूला है which is energy में m और v दोनों आते हैं?
Kinetic energy. Half
Excellent.
mv square.
Very smart. So kinetic energy का फॉर्मूला क्या है?
Half mv square.
Very good. Half mv square. अब kinetic energy कितनी दी हुई है? This energy they are talking about kinetic energy only क्योंकि moving है. It is obviously kinetic energy होगा. Plug in the values. Kinetic energy कितनी है?
0.48 joules.
Is equal to half. Mass कितना है?
2.5.
और v square. v निकल जाएगा यहाँ से?
Yeah.
Calculate and tell me the answer.
Yes. Miss, there's someone at the door. Could I just go check?
Sure.
Yeah. So it will be 0.62 meters per second.
Okay. V square कितना आ रहा है आपका?
0.384.
Okay. Perfect. चलो. So the value of V is how much?
0.62.
V square is equal to 0.384. So V is equal to 0.62. Unit?
Meters per second.
Question number 2.
Figure 2.1 shows a conveyor belt transporting a package to a raised platform. The belt is driven by a motor. The mass of the package is 36 kgs. Calculate the increase in the gravitational potential energy of the package when it's raised through a vertical height of 2.4 meters.
Okay. What is gravitational potential energy?
The formula?
होता क्या है gravitational potential energy?
For example, if you're like jumping on a trampoline, so the energy while going up is going to be the gravitational potential energy.
Yes. Okay. So when you gain height, it is gravitational potential energy, right? Okay. So what is the formula?
mgh.
So GPE is equal to mgh. How much is m?
M is 36.
How much is g?
10.
How much is h?
2.4.
Can we find out the rest of it?
Yeah.
Can we find out mgh?
Yeah.
Answer किस unit में निकलेगा?
Joules.
Very good. Good job, Sargun. I'm impressed. Very good.
So the final answer will be 864 joules.
864
joules.
joules. Okay. Next.
So the package is raised through the vertical height of 2.4 meters in 4.4 seconds. Calculate the power needed to raise the package.
Okay. अब power का formula?
Work done upon time taken.
Work done upon time taken. Power is equal to work done upon time. Work done तो है नहीं इस question में, तो हम work कैसे निकाल सकते हैं? Work उतना ही होगा जितनी हमारे अंदर energy होगी.
So work done will be 864 joules.
864 joules. Okay. Okay. Perfect.
And then the time taken is 4.4.
4.4. Very good. So what is the answer?
It will be 196.36 watts.
Very nice. तो अब हम इसको 3 significant figures में कैसे बोलेंगे?
So 196.
Okay.
Point.
And unit?
Sorry?
3 significant figures only, right?
Okay. So yeah, 196.
Or unit?
Watts.
Wow. Superb. Next question. Read the next question.
The electrical power supplied to the motor is much greater than the answer to B. Explain how the principle of conservation of energy applies to the system.
Hmm.
Or should I write my answer and then read it out?
Your wish, yes.
Yeah. So more electrical energy is needed as some of the energy will be wasted as heat energy because of friction between the motor and the conveyor belt.
Perfect. Superb. Absolutely correct. Sure. Next question.
Assume that the power available to raise a package is constant. A package of mass greater than 36 kg is raised through the same height. Suggest and explain the effect of the increase in mass on the operation of the conveyor belt.
Hmm.
So yeah. So The conveyor belt would have a slower movement as the mass put on the conveyor belt is more. When the mass increases, more energy is required, but because the power is the same, the movement will be slower. More mass means more gravitational potential energy.
Very good answer. Superb. Next question.
An athlete of mass 64 kg is bouncing up and down a trampoline. At one moment, the athlete is stationary on the stretched surface of the trampoline. Figure 3.1 shows the athlete at this moment. State the form of energy stored due to the stretching of the surface of the trampoline. Elastic energy, right?
Yes. Next. Next question.
Yeah. The stretched surface of the trampoline begins to contract. The athlete is pushed vertically upwards. She accelerates. At time t, when her upwards velocity is 6.0 meters per second, she loses contact with the surface. Calculate her energy at time t. Miss, could you scroll up?
Yeah.
No, like up, because I think the mass is given in the top of the question.
64 kgs.
Okay. So should I calculate and tell you the final answer?
Yes, yes, yes. You've understood how to do it, right?
Yeah, half mv square. Yeah, miss, so the final answer will be 1152 joules.
1152.
52.
Excellent. 152. So in three significant figures, what is the answer?
1150.
That is 1150 absolutely in three, and two significant figures, it is 1200 joules. So physics is two significant figures, okay?
Okay.
Now the next part. So in this question, what did we use? We used that since kinetic energy was 1200, and by law of conservation of energy, what do we know? Energy gets converted from one form to another. So this kinetic energy itself will get converted to potential energy, correct? To this potential energy. Hence, if this is 1200, even the potential energy will maximum be will maximum become 200. Will maximum become 1200. That will be the maximum potential energy. M you know, G you know, what will change? Only the H will change, and that H you can figure out. Okay?
Yeah.
Next question.
In practice, she travels upwards through a slightly smaller distance than the distance calculated in two. So just why this is.
Why is it so? These are all similar kind of questions.
Would it be because she's giving out less energy?
Reason? She travels upwards through a slightly smaller distance. जितना energy use हुआ उतना distance travel नहीं हुआ. ऐसा क्यों हो रहा है? Again the same thing, same reasons. क्यों ऐसा होता है? Because कुछ energy lose हो जाती है. वो कहाँ lose होती है energy?
As heat of friction.
It is lost as heat energy. क्यों? Because when you're jumping up, it's not just jumping up. There is friction. There is air resistance, right? You have to overcome all of that. So energy is lost in overcoming the friction and air resistance in the form of heat.
Okay.
Next.
Just 1 second, I'm just writing down the answer.
So in C part, what have we done? Can you explain this? Can you explain the answer? State the name of the point X. What is this point X?
It's the limit of proportionality because at point X, it's at its maximum extension and it loses its shape.
After that, it will lose the shape.
Yeah.
Okay. Okay. Then.
So
that X point is called as the
limit of proportionality.
And then what law is it obeying?
Hooke's law.
Till the point X.
Yeah.
After that, it is not obeying the Hooke's law. Okay. Next.
An electric train is initially at rest at a railway station. The motor causes a constant force of 360,000 newtons to act on the train, and the train begins to move. State the form of energy gained by the train as it begins to move. Kinetic energy.
Kinetic energy. Okay. Next part.
The train travels a distance of 4 kilometers along a straight horizontal track. Calculate the work done on the train during this part of the journey. So work done is force into distance. So the distance is given, but the force isn't. So how will you find out the force?
Work done, you said, is what?
Force into distance.
Okay. Okay. What else? और क्या है? Work done कितना होता है usually in terms of energy?
So work done is equal to energy transfer.
Calculate the work done on the train during this. The train travels a distance of 4 kilometers along the straight. Okay. Force into distance होता है work done. Okay, ठीक है. So यहाँ तो बिल्कुल straight question है. You have the force and you have the distance. निकल जाएगा आंसर.
Oh, okay. Yeah, right.
Right?
You get top part. Yeah.
Next part. अब इसका आंसर निकालो पहले आप. And then we'll move to the C part. Third part. This one says after traveling 4 kilometers, the train reaches its maximum speed. It continues at this constant speed on the next section of the track, where the track follows a curve which is part of a circle. State the direction of the resultant force on the train as it follows the curved path. So whenever you're ध्यान से देखना, whenever you're moving in a curve या फिर circle. So circle is like a curve, so I've made this. तो क्या होगा जब भी हम कर्व में जाते हैं तब there are two kinds of forces which are acting. One which is making you move towards this side and one which is towards the center. दो तरह के forces. और इन दोनों के force का resultant होता है जिसकी वजह से ये बीच में घूमता है इस तरह से. ठीक है? Are you getting my point?
Yeah.
Because of the force एक जो इस तरफ है और एक अंदर की तरफ है. आपने ध्यान दिया होगा कभी एक पेन में आप अगर एक थ्रेड लगा दो और उस पर एक स्मॉल पेबल लगा दो और ऐसे घुमाओ, आप जैसे छोड़ोगे वो पूरा का पूरा उड़ करके चला जाता है, दूर जाता है. So that happens because when you were moving it like this, you were kind of pulling towards yourself. एक अंदर की तरफ एक फोर्स लग रहा था और एक फोर्स बाहर की तरफ है. ये दोनों जब मिल जाते हैं तो इनका रिजल्टेंट बनता है बिल्कुल बीचों बीच, जो कि सर्कल में उसको घुमाता रहता है. करेक्ट. सो ये दिस इज आस्किंग अस state the direction of the resultant force on the train as it follows the curved path. So direction of the curve is जो कि अंदर की तरफ जो फोर्स आता है towards the circle आता है उसको हम बोलते हैं centripetal force. So what is the force towards the side, which is the centripetal force. And जो बाहर की तरफ उसको लेके जाता है ना, that is the centrifugal force. याद रखना, जो अंदर की तरफ आ रहा है that force is centripetal. So this one is what? The centripetal force. Clear?
Yeah.
चलो एक ये shall we, how many questions? Only 2 questions are left. Let's do it in the next class now. Okay. Stop here today.